Hello everyone, and welcome to the Mat 211 review of random variables, discrete and continuous. So this table here shows you the number of males for a certain year separated by their age group. And notice that the table is in millions here. So we have between 0 and 20, we have 40 million males there. Between 21 and 40, we have 15 million males. We have between 41 and 60, we have 30 million males, and 61 and older, we have 12 million males. We want to find the probability distribution that corresponds to this table. So we can think of each age group here as being an event. So an event that needs to be satisfied. So we would have the event that somebody is 0 to 20, or the event that somebody is 20 to 21 years old, and etc. So what we want to do is we want to find the probability by finding the total sample space and dividing each of these counts in millions of individuals in these groups by the cardinality of the total sample space. We can assume that these, 4 counts here comprise the whole sample space because it can't be less than 0. And 61 plus encompasses every age range after that. So everything and, up through however the oldest male is. So we can just say that, our total sample space is the sum of all of these different counts in millions, of course. So if we say that S is our total sample space, then the cardinality of S, which is the number of elements in our sample space, is going to be equal to 40 million. And we'll just keep this in millions. We don't need to write million in here because we know everything is in terms of millions here. So it's going to be 40 plus 15 plus 30 plus 12. So all these different counts. And this equals 97 million, which is the cardinality of our sample space. Now, each one of these individual counts represents the cardinality of the individual event space. So the event that somebody is between 0 and 20, that event space has a cardinality of 40, and so on through these. If this is the event, then the cardinality of that event space is 15, and so on. So we know, assuming that, the probability of being in any one of these is, kind of equally distributed here, then we know that the probability, so for instance, being in 0 to 20 is going to be the cardinality of the event space, 40, divided by the cardinality of the sample space, 97. So we can create a little table again to represent our probability distribution here. So let's make our table over here. And we're going to have little x representing, the event that, or the actual value that some x, if we treat x as our variable here, then the value that x takes is little x, which I'll denote with this little kind of curly looking x here. So then the probability that big X takes on one of these little x values is going to be on this side. So little x can be these guys here, these different events. So that would be, oh, don't need that in parentheses. That would be 0 to 20 for this first one, 21 to 40 for the second, 41 through 60 for the third, and 61 plus for the fourth. Then the probability of these is going to be 40 over 97 for 0 to 20, that event, For 21 to 40, we'll have 15 over 97. And similarly, for 41 through 60, we've got 30 over 97. And 61 plus is going to be 12 over 97. So this, we erase our little erasers here, or lines here. This is going to be our solution. This represents the probability distribution for this number of males, the number of males in our sample space. So that's it. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find at our main website page here, or by going directly to the tool at this full link here. There we go. So thanks so much and have a great rest of your day.